since we've been talking about how stars form and the evolution of stars, I thought it was about time that we looked at some cool pictures of stars forming or stars themselves or evolution of stars. So this right here is from the Eagle Nebula. Eagle, yeah, I should capitalize the E. This right here is from the Eagle Nebula. And just so you know, the word nebula is kind of a general word for any interstellar cloud of gas or dust. So when we're talking about the Eagle Nebula, we're talking about a huge nebula, and it's a nebula that spans. And just so you have a sense, this is just one of the pillars this is called the pillars of creation. You've probably seen this image before. There's these three pillars here, and this is just a small part of the actual Eagle Nebula. And just this pillar right over here, just this pillar here, just so that you have a sense of how large it is. How large it is. Just this pillar itself is 7 light years. It is 7 light years tall. So this is an enormous amount of distance. Remember, the distance from Earth to the nearest star was about 4 light years. It would take Voyager, if it was pointed in the right direction, at moving at 60,000 kilometers per hour, it would take Voyager 80,000 years to go 4 light years. Just this pillar is 7 light years. But I wanted to show you this because these type of nebulae, as the plural of nebula, are where stars can form. So this right here, you actually see this is actually kind of the breeding ground for the birth of new stars. This gas is condensing, just like we talked about a couple of videos ago, until it gets to that critical temperature, that critical density, where you can actually get fusion of hydrogen. So this is just a huge interstellar cloud of hydrogen gas. And over here, you could just see it's just this breeding ground for stars. And we actually think that this structure doesn't even exist anymore. Because remember, this thing is very, very far away from us. In fact, it is, just so you have the number, this is 7,000 light years away. 7,000 light years away, which means that what we are seeing now, the photons that are reaching us right now, reaching our eyes or reaching our telescopes right now, left this region of space 7,000 years ago. So we're seeing it as it was 7,000 years ago. So a lot of this gas, a lot of this hydrogen may have already condensed into many, many, many more stars. So the structure might not be the way it looks right now. And actually, there was another supernova that happened that we think might have kind of blown away a lot of this dust, and we won't even be able to see what the effects of that supernova were for another 1,000 years. But anyway, this is just a pretty amazing photograph in my opinion. Especially, and it's beautiful at any scale, but it's even more mind-blowing when you think that this is a structure that is 7 light years tall. And this is really just part of the Eagle Nebula, one of the pillars of creation. This right here is a star field, and this is as we're looking towards the center of our galaxy, the Milky Way. So this is the Sagittarius star field. And what I just wanted, the neat thing here is you just see such a diversity in stars. And this is also kind of mind-numbing because every one of these stars are inside of our galaxy. This is looking towards the center of our galaxy. We're not looking at, this isn't one of those where we're looking beyond our galaxy or we're looking at clusters of galaxies. This is just stars here. But what's neat here is you see a huge variety. You see some stars that are shining red right over here. And obviously, the apparent size you cannot completely tell because the stars are at different distances and at different intensities. But the redder stars, these are stars at their red giant phase. Or they're probably at their red giant phase. I haven't done specific research on these stars, but that's what we suspect. Those are at the red giant phase. The ones that are kind of in the yellowish white part of the spectrum, these are stars probably in their main sequence, probably not too different than our own sun. The ones that are in the yellowish white, or closer to orange, yellowish white part of the spectrum. And the ones that look a little bit more bluish, or a little bit more greenish, these are burning super fast. Let me see if I can find. This one looks a little bit bluish to me. These are burning. Sorry, I had to pause the video for a cough. These are burning super, super fast. And so the supermassive stars, they burn kind of fast and furious and then just die out. While the smaller stars, the ones with less mass, they burn slower over over a much, much, much longer period of time. So the ones that are burning really fast are emitting a lot of energy at the the smaller wavelength part of the light spectrum, and that's why they look bluer or greener. And these are going to be more massive stars, the ones that look whiter or bluer, greener, while the redder ones are less massive stars that are in kind of their supergiant phase, and so they are at this point cooler than kind of the main sequence stars. This right here, this right here is the Cat's Eye Nebula. And the word nebula, this is actually a planetary nebula, and I want to differentiate it. This right here is a planetary, this is a planetary nebula. And it's called a nebula because it is kind of this gas that's kind of floating out in space, but it's at a completely different scale than this nebula, than the Eagle Nebula that we drew over here. So normally when people just talk about nebula, they're talking about something like the Eagle Nebula, this huge masses of interstellar gas. When people talk about planetary nebula, this is still actually a huge, huge radius, but nowhere near 7 light years. But it's still a huge. But this is the byproduct of a star shedding off all of its outer material. So this is at the center of this, we see a fairly mature star here. And it's shed off kind of its outer layers. And it did that while it was in its red giant phase. So the core would keep flaring up, keep having these hot explosions. And every time you had one of those hot explosions, you had more and more of its outer layers getting pushed off into space, forming this planetary nebula. So this, as we see it right now, it's still not yet a white dwarf. It is still an active star. Fusion is still occurring in this star, but it's well on its way to becoming a white dwarf. Once all the fuel runs out. So it's past the red giant phase. It's thrown all of this material into space, and it's on its way to becoming a white dwarf. Anyway, hopefully you enjoyed that. I actually find all of these images to be pretty captivating, especially the star field one, because this is just inside of our galaxy. So hopefully it gives even more appreciation for how many stars there are. I mean, this is just a small fraction of the 200 to 400 billion stars inside the Milky Way.